Assalamualaikum. My name is Akalil Bermat Sultan and I'm from Malaysian Institute Aviation Technology. Today I want to teach you about optic lights. Optic lights. Definition of optic lights. Optic is a branch of physics which involves the behavior and properties of lights, including its interaction with matter and construction of the element and of instrument that used to detect it. Glass prism. Distribution of light by prisms. These colors are often observed as light pass through a triangular prism. Upon passage through the prism, the white light is separated into its component color, which is red, orange, yellow, green, blue, and violet. The separation of visible light into its different colors is known as dispersion. Next, electromagnetic spectrum. The electromagnetic spectrum is the range of all possible frequencies of electromagnetic radiation. The electromagnetic spectrum of an object has a different meaning and is instead the characteristic distribution of electromagnetic radiation emitted or absorbed by the particular object. This is the table of electromagnetic spectrum. Law of refraction. In the diagram, the ray of light approaching the mirror is known as the incident ray. The incident ray, I, labeled by I in the diagram. The ray of the light that leaves the mirror is known as the reflected ray, labeled R in the diagram. At the point incident where the ray strikes in the mirror, a line can be drawn perpendicular to the surface mirror. The line is known as a normal line. It's known as the left at the end. The normal line divides the angle between the incident ray and the reflected ray into two equal angles. The angles between the incident ray and the normal lens is known as the angle of incidence. The angle between the reflected ray and the normal is known as the angle of reflection. These two angles is labeled with the Greek letter theta, accompanied by a subscript read as theta I for angle of incidence and theta for angle of reflection. The law of refraction states when a ray of light reflects off a surface, the angle of incidence is equal to the angle of refraction. Next, color combination. As you see at the diagram, R plus G equals Y, R plus B equals M, G plus B equals C. This demonstrates with color box illustrate that the red light and green light add together to produce yellow light. The red and blue light add order to produce magenta and light. Green light and blue light add to produce clean C light. And finally, the red and green and blue add together to produce white light. This sometimes demonstrated by the following colors, equation and graphic. As you see, yellow, magenta, and clean are sometimes referred to as secondary color of light, since they can be produced by the addition equal intensities of two primary colors of light. This addition of these three primary colors of light is varying degrees of intensity with result in countless other colors, and we are familiar with. Convex mirror. As the image in the diagram above is a brittle image. This is an example of convex mirror. And you can read from this to get more explanation. Concave mirror is the second one type of after convex mirror. The concave mirror is a mirror that is curved inward in the middle. This is the example of the concave mirror. Convex lens is about the lens. Convex lens. This method of drawing ray diagram for the object placed at various locations in front of double convex lens. To draw these ray diagrams, this ray of the convex, we will have to recall three rules of refraction for a double convex lens. You can read for more information at the internet. This is about concave lens, the second lens. The lens formula that can be used to work out The position and nature of the image formed by lens can be expressed as follows by this formula, where U and V are the distance of the object and image from the lens, respectively, and F is the focal length of the lens. Okay. Second is refraction. Refraction based on this above diagram. Okay. You can read the material and the type of material: vacuum, air, water, carbon, disulfide, metal iodide, and diamond. Okay. Next, the reflection. As you know, reflection in the mirror in the diagram at left, where right light ray PO strike a vertical mirror at point O. This is point O, and reflected ray at OQ by projecting an imaginary line to the point of perpendicular to the mirror, known as the normal line. This is the normal line, straight 90 degrees. We can measure the angle of incidence and then the angle of reflection. This is symbol of angle reaction. Law of reflection states that the formula is this, or in other words, the angle of incidence equal the angle of reflection. Light refractive index. Okay. You can read this for the information and the reflection at the critical angle. This is the reflection at the critical angle, the examples that I can show you. Okay. Third is index reflection of water. You can see this is a stick is immersed in the water will appear to bend below the water level. This is applied when you see a fish in the water. This is the refractive of water. Next, index reflection of air. The index of reflection of vacuum is considered to be the bench refresh as below. And you can see air go through the water, and it is called the vital point is called the mirage in the air. Okay, next, the index refraction of glass. The index of refraction of glass is a very important information because we use glass materials in many situations in real life. This is very important of index refraction because glass we use in our daily life. The most common used type of glass are crown glass and flint glass. The two types the most popular we use. Okay. Next, negative index refraction. Okay. It also have a negative index refraction. Some materials with negative permeability and negative permeability found have negative index refraction. I repeat, some materials with negative permeability and negative permeability. You can read for more information in the internet. Okay, wave, motion and sound. Okay, this is wavelength. You can see this is the symbol, and amplitude is the power, time. One oscillation frequency is the number of oscillations per second. You can see this by the diagram to more understand. Okay. Second is mechanical wave. Mechanical waves are waves which propagate through a metal medium. Three medium: solid, liquid, or gas, at a wave speed which depend on the elastic and inertial property to the medium. These are two basic types of wave motion for mechanical wave: longitudinal wave and transverse wave. Okay. As you know, have two types of wave: longitudinal wave and transverse wave. Okay, the first type, transverse wave. Transverse wave is a moving wave that consists of oscillation occurring perpendicular or right angle. Okay. This is a type of transverse wave. You can see on the diagram to more for recognition. Okay. This is an example of transverse wave. You can see radio wave, light wave, thermal radiation, X-ray example. Okay. Second type is longitudinal wave. You can see on the diagram to make you more understand. Longitudinal wave is known as I wave. Okay. Example of longitudinal wave. You can see this sound wave is one of the example. Okay. Radio wave. Okay. Okay. And the wave characteristic. When waves travel along a rope or spring or across the surface of water, they set up regular patterns and difference. This is the frequency. The formula: wave speed ms per second is equal to frequency, hertz times wavelength, and the symbol of m. Okay. Interference wave and standing wave. One character of every standing wave is the that points along the medium that appear by standing still. Okay. Next. Okay. Interference wave and standing wave. One character of every standing wave pattern are the points along the medium that appear standing still. Okay. Next. Okay. You can see sound. Sound is a mechanical wave. This is type of mechanical wave. From the back and forth vibration particles of the medium through which the sound waves moving. Okay, that is the type of sound. Sound wave is a type of mechanical wave, as I say just now. Speed of sound in the air. These are the formulas that you read for more information. The example of sound frequency. Okay, frequency is directly related to wavelength, as you know. Okay, wavelength is equal speed of sound or frequency. Okay, this is how you can get more information and study by yourself for more good information. Sound propagation. Okay, this was discovered in the 1654 by Otto van Guericke. Okay, Otto van Guericke discovered sound propagation. Okay, let an electric bell be enclosed within a bell jar which is placed over a disc. Through a hole in the disc, air can be removed by using a vacuum pump. This is the application of sound propagation. Next, mesh number. As you know, mesh number is a ratio object speed over speed of sound equal to mesh number. How to calculate mesh of number? This is the formula that you can use. Okay, resonance. Resonance, as you see the two turning fork. This turning fork resonates at the frequency of the turning fork that was struck. This turning fork is struck, the rubber magnet for the striking turning fork. This striking, the resonance will occurs. Okay. Resonance and standing wave. Okay. This is type of resonance and standing wave. You can see standing wave. Resonance achieves when energy is added to a system at the same frequency as its natural frequency. Okay. This is an example of resonance, standing wave. Okay. Okay. Thanks for the audience to hear my speech, and that's all for today.